The topic is page replacement algorithm in operating system. I am Pavitra, assistant professor in the Department of AI and DS, SRO Madurai College for Engineering and Technology. First of all, you already know each process will be executed in the main memory, but the size of the main memory is what? Finite. Sometimes the process size is larger than the main memory, so the process is divided into the equal size of pages. Here, the CPU needs only the specific one, this page to be loaded into the main memory. Suppose these pages are in secondary memory, we are loading the required pages in the main memory. If the required pages is in the main memory, that the thing is called hit. If the needed page is not in the main memory, it is said to be a miss or page fault. Suppose the main memory is full, you can't put the requested page in the main memory. At that time, the operating system to decide, obviously, some page has to be swapped out or into the secondary memory. The new requested page is swapped into the main memory. Now, which page is to be replaced? That the thing is decided by the page replacement algorithm. Here we are going to see about what is page replacement algorithm, need of page replacement and types of algorithm and its problem. Page replacement. Page replacement algorithm or techniques used in the operating system to manage memory efficiently when the virtual memory is full, when a page needs to be loaded into the physical memory and there is no free space. These algorithms determine which existing page to be replaced. Here, the need of a page replacement algorithm is main objective is page replacement algorithm is to minimize the number of page faults and it decide which page to be replaced by which one. Here the diagram shows which page is swapped in and which page is to be swapped out from the main memory and the secondary memory. Here the OS maintains the page table. It has the information about the valid and invalid bits, which page has to be swapped in and which is replaced by what pages. These are all the things inside in this page table. If the required page is already in the main memory, it will be mentioned by valid bit. Then if the page is not in the main memory, it can be mentioned by invalid bit. These are all the things are in the page table. Here, these are the types of page replacement algorithm. FIFO page replacement algorithm, LRU page replacement algorithm and optimal page replacement algorithm. Now let us see about the first page replacement algorithm, that is FIFO. It maintains the queue order. First in first out page replacement algorithm. So the name itself saying that first in first out. So whatever the first we are enter into the page, that page has to be deleted first. So it is a very simple algorithm and easy to implement. So the replace the pages that has been in the main memory, it has the longest time in that memory. That page is replaced by the existing one. Let us consider the example. Now I am taking some reference string. Here the reference string is 312165113 with the page frames. Here the page frame specifies the main memory page framing numbers 1, 2, 3. Let us try to find the number of page faults. Here the pages are the reference string. The frames are 3. First one, 3 is placed. First one, the frame is empty. So the OS check the first reference string is 3. It can be placed in first order. So it will be specified by miss. Then it will check the another reference string is 1. It will be placed above the 3 and the third one is 2. It will be placed above 1. Then it will check the another reference string. So the memory have only the 3 frames. So we can't place the next string value. At that time it follow the FIFO order, which can be replaced by which one. How it is replaced by? It will be following the FIFO order. Whenever you start in the main memory, now the control transfers to the OS and OS to disk. From that we are getting the required page and it will be placed it into the main memory. So it is called as a page fault. The page is not in the main memory, that you call it as a page fault or miss. Next, the CPU is demanding for the next reference string. So it is page 1. Here it is already presented in the memory, so you no need to replace it. So it can be called as a hit. Then the next reference string is 6. 6 is not in the main memory, so it will be replaced by the longest oldest string is a 3. Here 3 is replaced by 6. Then the reference string is 5. We can't place that value, so it is not in the main memory. It will be fetched into the secondary memory. So the second one is longest or oldest one is number 1. It will be, the 1 will be replaced by 5. Then the reference string is 1. Here 2 is the oldest one, it will be replaced by 1. Then the reference string is a 3. 3 is already in the 3 is not in main memory. It can be fetched into the secondary one and 3 will be replaced by 6. The advantage of FIFO is simple to understand and implement, and it does not cost more overhead. The disadvantage is poor performance and it suffers from Bilady's anomaly. What is Bilady's anomaly? The Bilady's anomaly is when we increase the number of frames, it also increases the number of page faults. Here we increase this number of page frames. It also increases the number of page fault ratio. This problem is said to be Bilady anomalies problem. But LRU and optimal will never suffer from this Bilady anomaly. FIFO only suffer from this Bilady anomaly problem. Here we see about the FIFO algorithm. The efficient one is the optimal page replacement algorithm.